What's up to you all, pre-matriculants? Welcome to our lovely Triple M Day. It is a Mindsetters Maths Monday. If you're joining us for the first time, welcome to it. This is the best show ever. You learn more and learn extra. My name is Abram and I'm with Dina today. Dina, how are you?
I'm doing really, really well and looking forward to another stunning Grade 11 show.
Nice one. I can't wait already. What are we doing?
We are going to be looking at that topic that is now covered in paper 1, and it's called probability.
All right. More similar to what the maths lit guys do. But I know this one, it's more advanced. Well, my tip is to be part of our show. Make sure that you log on to Facebook on facebook.com/learnextra. Like the page, share the page, tell all your friends to be on our page. Help one another as well on the page. And if you have some questions, we're here for you guys. Shoot, because Dina and I are ready to answer you guys. On Twitter, follow us at LearnExtra. Remember, on Facebook already, we've posted 3 links for you. It is the viewing, the download, and the test yourself link. On the test yourself, if you answer the questions correctly, you stand a chance of winning this awesome Casio calculator, and a winner will be announced later on the show. And lastly, if you've been entering our Get Connected competition with prizes proudly sponsored by Vodacom, well, hold your thumbs because cross your fingers rather, because we'll be announcing 3 lucky Mindsetters who have won airtime 55 Rand from Vodacom. So stay tuned. It's going to be an awesome show. Dina?
I'm so looking forward to this afternoon, Grade 11s, and I must just ask you to please go on to the test yourself questions and really try and see if you can do some of those. But most importantly, Grade 11s, is that challenge question. We want you to try and solve it on your own. And right at the end of the show, we will work through the answer. And obviously, I get very excited when some of you that are very brave post your answers on the page. So I'm waiting for answers, Grade 11s. I'm waiting. And we'll do a little shout out for the first one who sends out the answer and it's correct. So Grade 11s, without much ado, we'll go straight on to what probability is all about. I'm not going to go through the theory because you've had it in grade 9, you've had it in grade 10 as well. Probability, basically the study of whether an event can occur or not, and it's a value that we give. It's a theoretical value, it's not a practical value that we give to an event happening or not. And we go from a value of 0, where something won't happen, to a value of 1, where it will happen. For example, you will die is got a probability of 1 because that event will happen. And then we sit with probabilities between 0 and 1. So we'd like to look at the 2 concepts that are most looked at this stage in grade 11 going to grade 12, and that is the occurrence of mutually exclusive events as well as independent events. So let's have a look at our little notes and what we're doing today. Okay, so we're going to look at the techniques that we use in solving probability problems. We're going to look at specifically tree diagrams, Venn diagrams, the addition rule for mutually exclusive events. The probability of A and B happening is the probability of A plus the probability of B. In fact, let's just correct this. It's not and. It's actually or. And the identity for independent events is the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. And then we also have the identity for the product rule for independent events, and that is the probability of A and B is the product of those 2 probabilities. So I want to actually focus on, let's just go on to the next slide there. Okay. Right. This word, mutually exclusive. Okay, because for some of us who are not English language speakers, we sometimes battle with what that word represents in mathematics. And mutually exclusive is really when 2 events are happening and they don't have any intersection. And I like to look at Venn diagrams to describe how this actually happens, and I'll show it to you in a little while. But we want to look at what is the meaning of that, and also the identity for the probability of A or B. What does that mean? and then we're looking at the product rule as well. So I actually want to look for a little slide that we can talk a little bit about that. And if we look at two events, A and B, and we're going to call them A and B because that's often how we refer to, we talk about a sample space as the space within which these events are taking place. So we would call the number of items in that sample space. And then if we have event A and we have event B, happening, because there's no elements that are intersecting, we say that the probability of A and B, there is no intersection, is 0. So the probability of A and B, and refers to the simultaneous elements that are happening for A and B, whereas the probability of A, and we can also write that symbol and can be written as an intersection symbol like that, it's also equal to 0. And we really speak about the two events being mutually exclusive when either one or the other happen, but the two events are not happening at the same time. So if we then look at what is the probability of A or B, how is this different from the and? And in mathematics, those two words and or have got a specific meaning. It's not like in English, where if you want to talk about you and your friend are going to the shops, if you talk about you, comma, your friend, and you're going to the shops, you understand the context that two people are going to purchase something at the shops. But in mathematics, it means that there's an intersection. There are elements. We talk about the elements that are in a set, and those elements are common to both sets. So we talk about an intersection. Let's just undo that. So we talk about an intersection. And the intersection means we're talking about common elements. Okay, that which is common to both sets. When we talk about or, we're talking about the union of the elements or all elements in both sets. Okay, so I want to illustrate this by means of an example. And if only our page would move down. Okay. I want to illustrate this by saying, if we have a set A, I'm going to draw this nice and large. And I draw this as sets that are now intersecting A and B. And let's say these are the fruits that someone likes. So we'll talk about a kiwi and an apple and some grapes. So person A likes all these fruits. And person B likes a banana. They like bananas, they like pears, and they like oranges. Notice that if I had to take the intersection of these two sets, person A and person B don't have any common fruits that they share. This person likes those, that person likes that, but they don't share any. Now, if I asked you to list all the fruits that these people like, then all the fruits would mean A union B And this would mean that my set would have the kiwi, the apple, the grapes, the banana, the pear, and the orange. This would be A or B. I'm listing all the possibilities that are in the set. Whereas if I have A intersection B, then I only want the elements that are common to both. And at the moment, I have got no intersection. It's an empty set. Just want to go back over here. The and, this is actually incorrect. Let's just correct this. A intersection B. Okay. The union is A. The union is A union B. Union for U for union. So it's all the elements. Intersection, just the common elements. Now, I'm going to put a common fruit in here that they all like. And we possibly can talk about maybe a lemon, maybe a strawberry. So let's just put berries. And we are not too happy with those berries. So let's talk about berries in general. So both these people like berries. Now, in this set, in the union set, it contains those fruits and it contains berries. But the intersection would now be the set containing berries. So all fruits listed in all teams, in all sets, this one would only be the one that's common to both sets. Okay, so that's a little bit of language and understanding the ors and the ands. Let's get to the challenge question, which I think some of you have been working on. It is posted on the page. There's a lot of writing. I'll let you go and read it so we can get on to our question 1. Okay, so grade 11s, you know me by now. We've been working together for the whole year. And what have I said to you about working with text? If a question's got text, what do? You read it 3 times. The first time you want to read so that you can understand where you are positioned. Where does this question position you? Where are we? What are we dealing with? The second time you read it again, you want to extract all the mathematical bits that are important to the context. And the third time you read it, you want to make sure that you've actually extracted the correct piece of information. So let's read the context. During summer in a certain city in South Africa, the probability of a sunny day is, and the probability of a rainy day is 3/7. If it is a sunny day, then the probability that Vusi cycles to work, the probability that Vusi drives to work, and the probability that Vusi takes the train. Okay, so we can stop there. We know we're talking about a city, and we're talking about whether it's rainy or not raining. So a rainy day or a dry day. And so it gives us all that information, and then it says, draw a tree diagram. Okay, so if we read again, we'll look, it's rainy, and Vusi is going to work by 3 modes of transport. So we have some choices to make. So choice 1, is it a rainy day or is it not a rainy day? If it's a rainy day, then Vusi is going to work with 3 modes of transport. If it's not rainy, he's also going to take those 3 modes of transport. So let's go back and now extract the maths. During summer in a certain city in South Africa, the probability of a sunny day is, and we've left that out, 4/7. And the probability of a rainy day is 3/7. So we have the choice of a sunny day or a rainy day. So we can already start with our tree diagram. And we can talk about our choice of whether we have a rainy day or a sunny day. So my sunny day has a probability of 4/7, and a rainy day has a probability of 3/7. So my choice of 2 days. Then, if it is sunny, then the probability that we see he cycles, he drives, or he takes the train. And it gives me the probability of cycling, driving, and by train. So they're all there. So I can have choices. If it's sunny, then it can go those 3 ways. And if it's rainy, then it can also go those various ways. Okay. So I need to fill in on the branches what each of the probabilities is. So we have cycling 7/10, driving 1/5. So let's go cycling. Cycle. We've got driving and train. Drives and by train. And the cycling is 7/10. The driving is 1/5. And we're just extracting that information, and the train is 1/10. Then if it's rainy, he also cycles, he drives, and he goes by train. And those probabilities are, this time round, 1/9, 5/9, and 1/3. 1/9, 5/9, and 1/3. And while we finish off that tree diagram, we're going to let Abram just give us a bit of a break.
Thank you so much, Dina. Something that you didn't know, Dina, we've got 7 mindsetters that are always like our regulars on the page, and most of them are late today. I don't know what's wrong, but either way, I'm going to send a shout out to all 7 of you guys: Wendy, Brian, Daniel, Beskild, Mukove, Njabulo, and who am I forgetting? If I forgot you, I'll remember. Oh, Gift is the last one. Well, guys, after the break, I'll be announcing 3 winners for the airtime. Stay tuned. Welcome back, mindsetters. If you didn't see the challenge question, it's right there on the page. Just scroll down a bit. You are going to see it. We've posted it, so make sure that you answer it. Now, it's time for the draw. This is the Get Connected competition with prizes, proudly sponsored by Vodacom. I must say that Vodacom is being really, really generous with us, guys, giving us 60-55 Rand airtime. I mean, who can give you such? But thank you so much, Vodacom, and also for the Sony Xperia L cell phones. We've given away 3 cell phones, so 1 is to be given on Thursday. So do watch our show on Thursday, just before 7 o'clock. Watch that show, because that's where we'll be announcing the winner for the Sony Xperia L cell phone. Now, the 3 names, I'm going to draw them myself because Dina needs to focus on other things. Okay, 1, 2, 3, and I swear there's so many other names. Okay, let's see. Anesu Zandire. Anesu Zandire, congratulations. Lindoguhle Mahlangu, congratulations. And I think 1. It's a trick. Right, let's get another name. I think that was mine. Okay. And Onke Nwili. Congratulations to Onke Nwili, Anesu, and Lindoguhle. You guys are getting 55 Rand airtime, proudly sponsored by Vodacom. So thank you so much, Vodacom, for being so generous with us. To enter for the competition, make sure that you get connected with us on Facebook, because we do have these prizes that are proudly sponsored by Vodacom. But on that note, let me tell you about More Maths, which is an application that you guys can use to challenge yourself and also to challenge other mindsetters. All you need to do is to register on More Maths, which is momaths.org, and your key is 0JRN. 0JRN, and it is a very nice app. I must say that some mindsetters are saying on the page they've been using it to play. So it's nice that you play and also learn at the same time, because you also get to see the answers right there. But before I pass it to Dina for the last time, let me tell you about the Test Yourself questions. You do not use these questions just to win, guys. You test yourself to know. So guys, test yourself right now. The link is on Facebook, and you get to stand a chance of winning this awesome Casio calculator, as I'll be announcing last week's winner after the challenge question on the second break. So guys, right now you do have the challenge question which is posted for you guys, and I see you guys are engaging with me on Facebook, and some of your comments saying we're enjoying the show. Well, this is my best part. This is the best part of my maths, from Gift, Bafana, and Chabeleng, and other mindsetters who are very late. So guys, thank you for joining us right now, and back to you, Dina. Are you ready?
I'm ready, grade 11s. Congratulations to all the winners, and thank you to all the sponsors. That's fantastic. Right, I left you where we were in the middle of drawing that tree diagram, and just to get things nicely fitting on the screen, I've just redrawn it, and now let's answer the question. The question was, for a day selected at random, what is the probability that if it is a rainy day and Vusi will cycle to work? So, probability that it will be a rainy day and Vusi will cycle to work. Notice the word and, so we are taking the probability of the rain and the cycle at the same time. So let's go to our tree diagram and let's just put that down. What is the probability, we use capital P, for a rainy day and a cyclist, and Vusi the cyclist? Okay. Which I think it's a little bit crazy, but anyway, he thinks that he can cycle in the rain. So what is the probability of that happening? Now, you would take the probability of the rain, and you would then follow this branch. We don't want a sunny day, we've chosen a rainy day, and we want to choose the cycling route. So the probability when two events are independent, like this, is that you take, and I'm going to write it in white, that the probability of rain and cycling would be this 3/7 times the 1/9. Okay, and the probability of rain and driving would be 3/7 times 5/9. Why on earth is it doing crazy things like that? 3/7 times 5/9. And the probability of there being rain and Vusi riding the train would be 3/7 times 1/3. Okay, so just showing you how the different probabilities work. So our rain and our cycle would be our 3/7 times 1/9, which is 3/63. And then remember I said to you it's a value between 0 and 1. So if you wanted to really know what that value is, then you would just say 3 divided by 63, and we'd get a probability of 0,047, which is 48. So 0,48. So that would be equal to 0,048. We often take that to 3 decimal places, but do follow the instruction on the exam. Right, and then the last question is, what is the probability that Vusi would take a train to work? Okay, so now, if we were looking at the train situation, he takes the train here, and he takes the train there. So we have to consider the probability here, which would be a 4/7 times a 1/10, and this probability here. So there are two situations, two scenarios. It could be sunny and he takes the train. It could be rainy and he takes the train. So we would have the probability of taking the train. So we could say, if you wanted to be strictly correct here, that it would be a combination of sunny and the train together with rainy and the train. So we'd get this one here, we've got it up there, would be 4/7 times 1/10, 4/7 times 1/10, plus, because remember the or means we're adding the two options, would be our 3/7 times 1/3. So that would give us some values. If we just work it out here, of 4 divided by 70 plus 3 divided by 21. So that probability is a fifth. So it's 0.2. 0.2 probability of doing of just riding that train, but doesn't matter what the day is. So that really works on the tree diagram. We always set up our options, and then we work with the independence of the events, and we then work with either an and or a or set. Okay, so that's really deals with one aspect of probability, which is to work with the various options that are given to us in terms of events. Now we'd like to look at a scenario where it's a lot more intricate and we need to think a little bit. So let's see what our second question is. Right, it comes from a previous paper. Okay, we've done that. So let's just see, did we miss some questions here? Okay, if we have time at the end, we'll come back to that one. Let's move on to this question here. Okay, it comes from last year's March paper, and previously this was found in paper 3. Now it's been brought into paper 1. A survey is conducted among 174 students, and we've got the following results. Okay, draw a Venn diagram to represent the information. Okay, so what often happens is when you do a survey, you've got things that are categorized into certain sets, if I can call it that, and we now want to demarcate how these sets are working. So again, we read the problem 3 times. We have the context, 174 students are surveyed, and so many study life science, so many study physical science, so many study mathematics, life science, maths, physical science. So it looks like people were chosen and they were asked about, do they take life science, do they take physical science, and do they take maths? Now, give me the possible options that can exist. If you ask person A, they can be a student that takes all 3. If you ask a person B, they can be a student that maybe take 2 of them. If you ask person C, that person may only take 1 of them. And if you ask person D, maybe that person takes none of them. So as you can see in a survey, you will be able to categorize the various people into specific sets. What we're going to do with the Venn diagrams is we always start with where all 3 would be happening. So you would want to count the people where they were all taking life science, physical science, and mathematics. And then we work our way out, because it's much easier to work out than it is to work into the problem. So tell me how many people choose life science, mathematics, and physical science, because that's really what the context is. So notice we've given a broad perspective of what exactly is happening in the survey. We now want to go and dig. We want to get the mathematics out. So let's go and do that. Okay, so since it is a Venn diagram, we're going to just ask the page to cooperate with us, and we're now going to try and use up the space as best we can. So we have a set, always drawing a rectangle to indicate the sample space. Do you remember how many students were interviewed? 174. So our sample space always goes on the outside. I want to know how many take life science, how many take physical science, and how many take mathematics. Okay, so this is my life science set, this is my physical science, and this is my mathematics. Notice that the people in the middle here are the people that take all 3. They take all 3 subjects. The people in this branch here, some of them already take both, but these people here only take life science and physical science. These people here only take life science because there's no intersection with the physical science. These people here only take physical science, and these people here only take mathematics. So it is important to understand how those Venn diagrams are drawn and what information they give you. So who sits in the middle here? The person who takes all 3 subjects belongs to that set, belongs to this set, belongs to that set. What's happening to the people in here? In the set here, if I had to just work out what this yellow here is, this little branch. Those people only take life science and maths. They don't take the physical science. What about these people here? They only take physical science and maths. They don't take the life science. And these people here, they only take life science and physical science. They don't take maths. So what's left over is the people that only take the life science. So with a diagram like that, it's a powerful tool to visually capture what has taken us lots of time to actually collect. So let's look at the numbers now. So first of all, there's the context. And then the people outside the sample space, or not outside the sample space, but outside these diagrams are the ones that don't take any of those three subjects. So 37 study life science. We go back here. Where are those 37? They are inside the circle that represents life science. We don't know whether they're in here, whether they're in there, whether they're in there, whether they're in there. I just know that they're all inside here. So that doesn't give me enough information. Remember what I said just a moment ago? Where do we start? With the people in the middle. So let's go and find who should be in the middle. The 37 doesn't help me. I've got to go look for more information. Let's go look for more information. 60 study physical science. That still doesn't help me. 111 study mathematics. Still doesn't help me. 29 study life science and maths. Where are those people? Where are the life science maths people? Okay. They're inside the white and the yellow. So I know the total, but that doesn't help me because I don't know either of those two. So I'm still looking for more information. What do I want? The information that tells me where all three subjects are taken. So let's keep searching. 29 study life science, 50 study maths and physical science, 13 study physical science and life science. 45 do not study any of those subjects. Okay, we know where to put the 45. They're sitting out here. So these are the 45. That still doesn't tell me what's happening in the middle. Ex-students study life science, mathematics, and physical science. Ah, here's the magic. Here's the magic. What I was looking for. How many are taking all three subjects? And they've just given me that hint. They're saying to me, it is X number of people. Now, can you see earlier on, they told me how many were in the white and the yellow. So now I can go back and look for the intersections of the two sets. I've got the intersection of 3. I can now do the intersection of 2. Let's go and look for all the intersections of the 2s. Where are they? Here we go. 29 study life science and maths. 50 study maths and physical science. And we've got 13 study physical science and life science. Okay, so let's work on those. Life science and maths, 29. Life science and maths, 29. So in here are my 29 that study those subjects. But I'm now including the X that are doing all 3. So how many should be written in the yellow? Okay, 29 is my total for the whole lot, but X already study all 3. So inside the yellow, I'm taking away the ones that study also the physical science and life science and maths. So inside the yellow, I only now have the ones that are studying both those subjects. Okay. 50 take maths and physical science. 50 take maths and physical science. So therefore, that's the total minus the ones that already take all 3. So in the end, I'm only going to get a value for the maths and the physical science. And then we have 13 study physical science and life science. So I have that one is 13 minus X. Okay, so look carefully at how we've worked from the middle and we've worked out. So we know how many were studying all 3. We've been now able to work out how many are studying 2. Then, what do I need to find out how many study just life science? Okay, now the beginning information is now useful because I've got 37 study life science. What does that mean? That there are 37 in the circle, the life science circle. That plus that plus that are already in there. So what must go in here? 37 minus 13 minus x minus x minus 29 minus x minus 50 minus x. So inside here, I've got the ones that are taking only life science. And if we do those calculations, minus x will become plus, minus x will become 0, plus x. So I'll be left with an x, and 13 and 29 are 42. So 37 minus 42 gives me minus 5. Then inside here, physical science, what are they telling me? They're saying that 60 study physical science. 60 study physical science. So if we go down here, it will be, in total, I've got 60. Now I've got to take away these that are studying 3 and 2s. So 60 minus 13 minus x minus x minus 29 minus x minus 50 minus x. Okay, so we've got, again, the plus x, and what have we got here? That's 42. Sorry, this is just the physical science. So the physical science doesn't include the 29 minus x. I was already adding that in unnecessarily. So that would be, okay, so 60 minus 50 would be 10, and 10 minus 13 would be negative 3. So that would be a negative 3. Right, and finally, how many are taking maths? I think there were 111, if I remember correctly. 111 study maths. So in this circle, there's 111. So we now have 111 minus the ones we've already got, 29 minus x minus x minus 50 minus x. So that's going to again be x, and we've got 29 plus 50 would give us 79. So 111 minus 79, 8, so that's 32. X plus 32 would be that. So we've been able to tell you exactly how many are just taking life science, maths, and physical science. Okay, the first question is to draw the Venn diagram. It's for 6 marks, all these little bits and pieces. Let's see what the second question is. Okay, same thing. And we now have show that x is 13. How are we going to show that x is 13 from all this? Is we go to our diagram and we say that those amounts, the individual amounts, all those amounts must add up to 174. And you solve for x. So it's as simple as solving that equation. And I think AB's wanting to give you a little break.
Yes, I do, Dina. And I must say that, Mindsetters, we've got exciting news. Watch our channel. We are 7 days now before our big day. We're going to have a big reveal on the 15th of September. And do check out tomorrow between 6 and 7 o'clock. We're going to be having some clips just to help you through, guys, with your driving lessons if you are taking some driving lessons. But on the 15th of September, watch our channel, Mindset TV, because there's a big reveal that's going to be given to you guys. So I can't wait, but I must ask you, if you've done your learners, or if you're working on your driver's license, let me know on the page. But for now, we'll see you after the break. Welcome back, awesome Mindsetters. Now, I know that some of you really want to see the right answer for the challenge question, but before we go there, let me announce our last week's winner for the Casio calculator. And the calculator goes to Mpho-Tlaka. Congratulations, Mpho-Tlaka. This awesome Casio calculator is coming your way. I know that it's going to be useful for you, and keep on watching Mindset. If you'd also like to win, make sure that you answer the test yourself questions, as Dina said. They're simple, they're just to challenge you. Dina?
Right, grade 11s, congrats, Mpo. It's so exciting getting a new little goodies. Fantastic. Right, grade 11s, we're ready to do the challenge question. But before we do that, there was a query around why I was subtracting, in the previous question, why I was subtracting X when I was getting to the life science number. And that is because all these represent students that are also taking life science. They just happen to take other subjects with it, but they're taking life science. So if I'm told that the total number is 37, then I have to add up all these and take them away from 37. So either you can subtract X or you can just add them all up and then take them away in one shot. It's up to you. But just remind yourselves that all these represent number of life science students. These represent physical science. They just happen to take another subject. These represent the mathematics as well. They just happen to take other subjects. These in here are solely those individual subjects. So without further ado, let's see how many of you got the challenge question. The challenge question is again a Venn diagram about hockey, cricket and netball, and at a school there are 240 learners in grade 12, and the following information was gathered about participation in school sport, and it looks like there were 240 girls because 122 girls play hockey, 58 girls play cricket, 96 girls play netball, 16 girls play all three sports, 22 girls play hockey and cricket. Then we've got the 26 playing netball and cricket, and 26 girls who are not playing any of the sports. So it should actually be, gather about participation in school sport. Let the number of learners who play hockey and netball only be X. Okay, I'm going to try and do this Venn diagram. I hope that everybody will be able to see it in this little space here, so we don't have to toggle up and down. So let's put it in yellow. And okay, so the sample space is 240, and we've got learners playing hockey, cricket, and netball. So we have the hockey, we have the cricket, and we have the netball. And what did I say to you earlier? Where do we begin? We begin where all three, where a person takes all three of the sports. Let's go and find where that is. All three. Here we go. 16 play all three sports. So we've got all three is 16. Got 16 in there. Then they also tell us that the number of learners who play hockey and netball are X. So only, this word here is very important. I was just rereading it. It says only that is X. So hockey and netball is X, only that. And then we have 22 girls play hockey and cricket. So we've got the hockey and the cricket as 22, which means that that must be a 6. So earlier on, when we had the total 3 sports in the middle as X, it was difficult to work with the other 2. Now, it makes it much easier because it's 22 are playing hockey and cricket. There's my hockey and cricket. That means I know that in here, I have 22. But since 16 are already playing an extra sport, then only 6 are then inside that portion over here. And then 26 girls play netball and cricket. Netball and cricket, we have 26 in here. But if 16 are inside there, then that means 10 are in here. And 26 don't play any of the sports. So 26 are out here. So mindsetters, how are you doing? How's this thing looking on your side? Then I've got 122. They play hockey. And I'm running out of colors here. Let's just not do that one. Let's do it in yellow. 122 play hockey. So that means that in this yellow circle, there's 122. So how many are going to be just playing hockey, just inside here? How many in there? that would be 122 minus the 6 that are playing both those, minus the 16 that are playing all three, minus the x. And if we do that subtraction, we get 100 minus x. Okay, because that would be 22 minus x would be 100 minus x. Then we have, we can do that in green, we've got the ones that are playing cricket only. 58 girls play cricket, so 58 minus 16 minus 6, so 58 minus 22, 58 minus 32 would give us 58 minus 32 gives us 26. So this would be 26 play cricket. And then how many play netball? We've got the netball, 96 girls play netball. So we have inside this one, we've got 96 minus 10 is 86, minus 16 is 70 minus x. So that's 80 plus 16 is 96. Okay, so that gives us each of those portions, and we now need to determine the number of girls who play hockey and netball. So that was x. Let's find x. How many play hockey and netball would be solving for x. So we would add all those up, and they've got to give us, plus the 26 to give us 240. And grade 11s, yes. How many did you get for x? What was your x? What did the mindsetter say was the number, was x, netball and hockey?
Okay, let me see most of them. Sorry, Tina.
Did they give us 14? That's the netball and the hockey. So there were 14 playing netball and hockey.
Yes, 14.
Good. Well done, mindsetters. Then determine the probability that a learner in grade 12 selected at random, give your answer correct to 3 decimal places, only plays cricket. Okay, what would we do there? Well, we found out that there were 26 that play cricket. So if you'd chosen at random, it would be 26 out of 240. And if you're going to round it off to 3 decimal places, then our little magic machine will do that for us. 26 divided by 240 gives us a probability of 0,108. 0,108. If they don't play netball, we're the ones that don't play netball. Okay? All of these are playing netball. So it's those, and those that don't play netball. The ones that are playing both those sports, the ones that are playing only cricket, and those that are playing hockey. Because all these play netball. So we can extract all those. So 100 minus 14 is 86. 86 plus 6 plus 26. All the sixes. So it would be, let's go down. Okay, we're a bit slow this morning, this afternoon. So what is the probability of not playing netball? Okay, and we have 86 plus 6 plus 26 out of 240, and that probability is 86 plus 6 plus 26. And we're dividing that by 240, and we get a probability of 0,492. 0,492. Good luck, grade 11s.
Thank you so much, Gina. Well, mindsetters, we ran out of time, but I hope we've helped you guys. If you're still struggling, make sure that you go to our website, learn.mindset.co.za/help desk. That's where we can help you. But from me and the rest of the team, we love you and peace.